Let's look at domain and range of continuous graphs. What are continuous graphs? They are graphs, and instead of just our points, those points are connected with lines and curves. So let's break it down. First, let's look at domain. So remember, our domain is our x values. And on our graphs, in order to get our domain, to get our x values, I really do not know why it's not focusing like this. I don't know why it keeps changing. Let's see if that will work. Okay, sorry. We're going to scan our pencil from the left, so just like we read, from left to right along the x-axis because we are doing our x values. So let's look at this. This first one. We've got this graph that looks like this. So we are starting from left to right, and we want to label our domain. We want to talk about our domain. Instead of listing numbers this time, we want to talk about the numbers that it includes. From the leftmost number, leftmost x value, to the rightmost x value. So whenever I come over here to my graph on my leftmost x value, I see that we've got an arrow. Remember, our arrows mean it continues on forever and ever 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 and ever. And I can't tell you what the leftmost value is ever going to be because it's never going to end. Okay? So then whenever I scan over here, I see that it also has an arrow, so that's going to continue on as well this way, and it's never going to end. So when we have a situation like this, then we say our domain is all real numbers. And there's a symbol for that, and it's just this R that's got two lines, that extra line. Okay, let's look at number 2. We are scanning from left to right. I want to see what is my leftmost x point. Oh, it's right here. And if I start at the origin and going to that point, I go to the left 1, so that's -1. So if we've got arrows, then we're talking about some kind of infinity or some kind of all real number situation going on. If we don't, if we have a defined ending on either side, then we're going to write this as an inequality. Remember, our inequalities are symbols less than, greater than, less than, or equal to, greater than or equal to. So we've got -1 over here, and that is, we're going to denote that as, for our domain and range purposes, it's always less than or equal to. We're talking about domain, so that's our x. And then keep scanning, keep scanning. Oh, here is the rightmost value. And if I start at the origin, we go over to the right, so positive number 1, 2, 3, 4, 5. So that is less than or equal to 5. And what this is saying is that my x values included in this square on my coordinate plane are between the numbers -1 and 5. And we can see that. If I pull out this point, that's 1, 2, 3. That's a positive 3. Positive 3 is between those numbers, isn't it? Alright, we've got this straight line, so let's go over to the left. And when I'm coming over our leftmost value, we've got a arrow on this side. So that means it continues on infinity that way. And whenever I keep going on my x-axis, we've got another arrow going that way, so then we've got another situation where we've got all real numbers. Okay, let's look at our domain for number 4. So again, we've got from the left to the right. Leftmost x value, well, on the end here we've got another arrow, so that side's going to continue on forever. If I keep going over to the right, we've got another right arrow. that one side's going to also continue on. So if you got two arrows on the end, we might have this all real number situation for domain and or range. So now let's look at that range. Remember, our range is our y values. This time we're going to scan our pencil from bottom to top and along the y-axis. So let's look at what that is for these examples. So we're going to go from bottom to top. We're scanning this way. So let's find our bottommost point, which is right here. Remember, we start at the origin and we count. We went down, so that's going to be a negative number. 1, 2. So we've got negative 2. Remember, if we've got a defined point, we're using our less than or equal to symbols. We're dealing with range, so that is y. And then as we go up, we got arrows, so it means it's going to continue up forever. So we're going to include all of the y's above our negative 2, so we can write that as less than infinity. So our y values, our range, is going to be anything above this negative 2. So another way we could write this as an inequality, you might see this as well, is that y is greater than or equal to negative 2. And that's saying the same exact thing. Alright, number 2, we remember range is from the bottom to the top, Might be counterintuitive. So scan my pencil. My bottommost point is right here. So let's define that point. 1, 2, that's a negative 3 because I went down. Again, I'm using y because of range. Let's scan all the way up to the top. There's our topmost point. And we go up to a positive 3. One thing to note is it's not where the last point is, it's the top and the bottommost point. So on your class, you see something that kind of goes up and down. It's always the bottommost, not the last one. Alright, our range on here, bottom to the top, we just are here. We don't go anywhere above this line or below this line, and that line is y equals negative 4. Alright, our range here, starting at the bottom, we got arrows going down. So this time, these arrows going down is going to go on forever, so we're never going to get any ending point. So it's going to go on for negative infinity. We got y, and then let's scan to the top. Where's the topmost point? That one's right here. We got 1, 2, 3, 4.